Hello everyone. Today we are back with another question on LeetCode, that is majority element. So let's try to understand this. So this question is saying that we have given an array nums of size n and we have to return the majority element. And how they define the majority element? So the majority element is the element that appears more than n by 2 times. So let's say you have an array of size 10. Uh, and it is saying that the majority element is the element that will occur for n by 2 times, more than n by 2 times. So if you will see, then 10 by 2 is equal to 5. So basically, this majority element is the element in this array that we have taken, and it will occur for more than 5 times, as this 10 by 2 is equal to 5, which is half of the array, and majority element will be the element that will occur for more than 5 times. So this is the definition of this majority element, and you may assume that the majority element always exists in the array. So basically, we do not have to check the condition where this majority element will not exist, because this question is itself saying that it will always exist in the array. So let's try to solve this. Before solving this, we have to see this follow-up, that it is saying that you have to solve this problem in linear time complexity, that is in O of n time complexity, and in constant space complexity. So let's try to solve this. So this is the array we are taking to solve this. So the brute force approach that will come into our mind is to use some extra space. But the question is itself saying that we have to solve this problem in O of 1, that is in constant space complexity. But let's try to solve this with the brute force approach. So the first approach that will come into our mind is to take some extra space. So in this case, we will take a hash map to perform this operation. So what this hash map will actually do, it will store this nums array into the form of key and value, and key will be all the unique element into it, and the value will be the frequency of these element. So let's try to store them into the hash map. So first element is 2 and second element is 1, and these are occurring, 2 is occurring for 4 times and this 1 is occurring for 3 times. So what we will do, we will simply traverse into this nums array, and by traversing this array, we will simply store all of these elements into this hash map. This is the hash map. After that, what we have to do, we have to again traverse into this map. We will traverse into the map and we will extract this value for every key, and the key which has this which has the higher value will be our answer. So as we can see that this 2 has the higher value, that is 4, so it will be our answer, because it is saying the majority element is the element that will occur for more than n by 2 times. So it will be the element that has the higher frequency in the array. So we will simply extract the element from this hash map which has the higher frequency, and that will be our final answer. So this 2 is the final answer. But as we can see that the time complexity it is taking is O of n, that is linear time complexity, that is good. Now the question is also saying to take linear time complexity, but the space complexity it is taking is also O of n, that is linear space complexity. But the question is saying that you have to take O of 1, that is constant space complexity. So basically we have to reduce this space complexity. So basically there's a terminology that is called time space trade-off. There's a terminology that is called time space trade-off. So what does that mean? So this time space trade-off simply says that let's say you're solving a problem, and you have to solve a problem, and let's say you are decreasing the space. So when you will try to decrease the space, let's say initially you are solving a problem into O of n space complexity. After that you will decrease it to O of 1 space complexity. So while you decrease this space complexity, time complexity will automatically increase. And when you will try to decrease this time complexity, this space complexity is automatically increased. So this is what the time space trade-off. It is basically a trade-off between the time and the space. If you are increasing the time, so this space complexity automatically got decreased, and if you are increasing the space, then this time complexity is automatically get decreased. So this is what the time space trade-off. So here we are going to follow this time space trade-off, as this time is O of n, which is good in this solution, and this space is O of n, which we have to drastically reduce it to O of 1, that is in constant space complexity. So let's try to do this. So what we will do, the second approach to solve this question, although this is not the optimal approach, this is also the brute force approach. Here we are just following time space trade-off. What we are doing, we are just increasing the time, and when we will increase the time, this space complexity will definitely got decreased. So we are simply following this approach of time space trade-off. So what we will do, we will simply try to sort this array. So after the final sorting, this array will look like something like this: 1, 1, 1, 2, 2, 2, 2. So after the final sorting, this array will look like this. And after that, what we will do, we will simply return the element that comes in between. So we will simply return the element that will come in between of this array, in the middle of this array. So the middle element in this array is this 2. So this 2 will be your final result. Now let's try to understand why this 2 is the final result. As the question is itself saying, the element that will appear for more than n by 2 times, it will be the final more than n by 2 times. So it will be our final result. That is, it will be the majority element. So as we are sorting this array, and this majority element will definitely occur for more than n by 2 times. So it will take more than the half space of this array. So it will, after sorting, it will definitely take more than the half space of our array. So as it is taking more than the half space of our array, so simply we can say that the middle element also will include in this half space. So we will simply return this middle element, and that will be your final answer. And if we will try to code this solution, then the code is very simple. We can solve it in simple 2 lines. We just have to sort this array. And after sorting, we just have to return the middle element. So we will return nums of nums dot length by 2. So this nums of length by 2 will be the middle element. So we are just returning this middle element after sorting the array. Let's try to run this. So it is running fine. Let's try to submit it. It is also getting submitted. So this is the second approach to solve this question. But if we will try to analyze the time complexity and space complexity into it, so the time complexity is O of n log n. Because to sort the array, the minimal time complexity required is this n log n. We can sort this array in n log n time complexity by using any approach like merge sort like, or quick sort approach. And if you will see space complexity, then this space complexity is O of 1. So if we will compare these both the solutions, so in the first solution, the time complexity was O of n, and the space complexity was also O of n. And in this second approach, the time complexity is O of n log n, and the space complexity is O of 1. So this is what is the example of time space trade-off. Here we are just increasing the time from O of n to O of n log n. And what happened after that? It will simply decrease the space from O of n to O of 1. And we can also do vice versa. If this is the first solution, we are doing it in n log n time complexity, then we will simply decrease it to O of n, and it will simply increase the space from O of 1 to this O of n. So this is what the example of time space trade-off. But this is not the final solution, because as this question is saying that we have to try to solve this question in linear time, that is in O of n, and in O of 1 space, that in constant space complexity. So let's try to solve this in linear time complexity and constant space complexity. So to solve this question, using O of n space complexity and O of n time complexity. There is a standard algorithm. There's a predefined algorithm that is known as Morse voting algorithm. Morse voting algorithm. So we will use this algorithm to solve this question. So what we will do, we will initially take this element. We will initially take a variable and we will simply store this element of 0 index. So we will store this element here. And also we will take a counter, and this counter will initially be 1. Why this counter is 1? As we have taken this first element itself. So this counter will be 1. After that, we will try to traverse this nums array, and we will start this traversing from this first index. So let's try to traverse this from this first index. So what we will do, we will simply compare each and every element with this variable we have already taken. So simply start comparing it. So first, let me write the index for each and every element. So is this nums of 1, that is 2, is equal to element? Yes, this is saying that nums of 1 is equal to element. So what we will do in this case, we will simply increase the counter, as we have got another element which is similar to this element, this variable we have taken. After that, we will also increase this pointer. Again, we will check whether this 1 is equal to 2. Is this nums of 2 is equal to 2? That is 1 is equal to 2. No, 1 is not equal to 2. So what we will do, we will simply decrease the counter. We will simply decrease the counter and increase this pointer. Again, it will check whether this 1 is equal to 2. No, 1 is not equal to 2. So again, we will simply decrease the counter and make it 0. And this pointer will be increased. After that, again, we will check whether this 1 is equal to 2. No, 1 is not equal to 2. And as this 1 is not equal to 2, but now at this time, this counter is 0. So we do not have some another element that will be deducted from here. So what we will do, we will make our new element as this nums of 4. So we will simply cut this and make this as a newer element. And after that, we will also increase this counter as this element is occurring for one time. Okay, after that, again, we will move this counter ahead and we will compare whether this nums of 5 is equal to element. So, and it will say that this nums of 5 is not equal to element. So what we will do, we will simply decrease this counter and make it 0. After that, again, we will move this pointer ahead and it will also compare whether this 2 is equal to, also we will have to make this element as 2, as we have found this 2 here. So no, this will not happen actually. This element is 1 itself. After that, again, we will check whether this 2 is equal to 1. This 2 is not equal to 1. And at this time, this counter is also equal to 0. So it is saying that we do not have any element to deduct further. So what we will do, we will simply take this element and place it here in place of it 2. And we will simply increase the counter also. And this pointer will move forward. Now, as this pointer has crossed the limit, so it will terminate us out of the loop. So this element will be our final element. So what is the intuition behind solving this problem like this? So as the question is saying that the majority element is the element that will occur for more than n by 2 time. So if the element is occurring for more than n by 2 time, so it will simply take more than n by 2 space into the array, more than half of the space into the array, and the number and the frequency of this majority element will always be greater than the frequency of rest of the element. The rest of the element in total will definitely be lesser than the frequency of this majority element. So this is what this is the conclusion. So let me try to make you understand. So we have these 2 occurring for 4 times. So these 2 are occurring for 4 times. And this one is occurring for 3 times. Now, if we will try to deduct this element from this particular majority element, so this 2 simply deduct this one element, and this 2 will also deduct this element, this 2 will also deduct this element, and at last this 2 will remain. So this will be our final answer. So this is the intuition behind solving this problem like this. So let's take another example and try to understand this more clearly. So let's say we have an array. which is 2, 3, 3, 1, 3, 1, 3, 3, 3. So in this case, we can simply see that the majority element is this 3, as the frequency of this 3 is 1, 2, 3, 4, 5, and 6. So the frequency of 3 is equal to 6. And the size of this array is 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 9. And if we will do 9 by 2, then it is equal to 4.5. And this 6 is always greater than 4.5. So in this case, this 3 is the majority element. Now, as per the approach we have discussed above, if you will see that the frequency of these majority element will always be greater than the total number of rest of the element into this nums array. So if you will see this, then we will take the majority element at one side. So this 3 is occurring for 6 times, 5 and 6, and the rest of the elements are 2, 1, 1. So these are the rest of the elements. And if you will try to subtract this element with these majority element, then this 3 will replace this 2 element, this 3 will replace this 1 element, and this 3 will replace this 1 element. And finally, we are left with these 3 elements. So it will definitely be our majority element. So this is the approach behind solving this problem. So let's try to understand the pseudocode for this problem. So what we will simply do, initially we will take this as our first element. So the first element is nums of 0. So we will store it into this variable. After that, we will take a counter, which is initially equal to 1. After that, we will use a loop and try to traverse the whole array, and we will start from 1, the first index. And we will go till end of this array. Now what we will do, we will simply try to compare this element with this variable we have taken. So if nums of I equal to this element, what we have to do is simply have to increase the counter. Else, if nums of I is not equal to element, and also this counter is greater than 0, in that case, what we have to do is simply have to decrease this counter. Else, what we will do, we will simply make this element as the element we have. So we will simply replace this variable with the newer element. And as we have taken another element, so we have to increase the frequency of this counter also. So this will be our final code. So let's try to code this. We will take an element. This element is equal to the element which is at first 0th index. After that, we will take this counter, which will keep the track, the frequency of the element. After that, we have to traverse into this nums array. We will start traversing from the first index, and we will go to the last of the array. We increase the pointer. After that, we have to check the condition. If at any point of time, this nums of I is equal to the element we have taken, then we have to simply increase this counter. That's what we will do. If this nums of I is not equal to the element, and also the counter is greater than 0, then in that case, we simply have to decrease the counter. Else, what we will do, we will simply set this element as the newer element, and we have to increase the counter as we have got some new element. So we have to increase this counter and make it as 1 because we have got a new element. So this will be our final result, and after that, finally we have to return this element. And now, as if we will see these constraints, then the number of element will start from 1 and vary till range 5 into 10 to the 4. So basically we have to handle a base case also here. So if nums dot length equal to 1, in that case we simply have to return the same element because this will be the majority element. So return nums of 0. So let's try to run this. Okay, this counter will start from 1 because initially we have this element with us and this is accepted. And let's try to submit this. And uh, yeah, it is accepted. Basically, if you check in submissions, then it is accepted. Okay, so that's all for today. Thank you.